the stream seems to be running fine now. I had to switch my ISP for my mobile, since my mobile is better internet than my modem. And it's sad that I wanted to do this with another person. I cannot hear anything that the other person is saying, and I think this is mostly because of my Discord. Give me just 1 more minute and I will quickly fix it. I'll try to get on Discord from the web and see if it's any different. Hello, can you hear me, guys?
Yeah.
Okay.
Yeah.
Is it clear?
Yeah.
Okay, good. Okay. Are you ready for the lesson?
Yeah. What
Okay.
do we need?
Just the time, is it fine? And will you take part in workshop as well?
Yeah.
Hello. All right. Then we can start. I will also post on Discord that we are starting, and I'll give the link to my channel. And the slides itself will be posted in the announcements a bit later. Hello. Okay, let's wait 1 more minute and we'll start.
Okay.
Before we start, I would like to ask you, what do you think is a clean function, since this will be today's topic?
Use as little variables as possible.
Yeah, that's true. A part of it. What else?
All the data that you're referencing should be a parameter.
Sorry, I couldn't catch it.
All the data that you reference should be a parameter.
No.
Because that means you can.
That
means you can move the function between, software without breaking it.
You mean it should be modular? Yeah.
Yeah.
Yeah, definitely. By the way. Oh, sorry. By the way, do you hear me clearly on Twitch?
Don't know. Let me turn sound on. Say something.
Hey.
Yeah, it sounds fine.
Okay. I recommend putting Twitch on mute, and so we have no delays between conversations. I'll be swapping slides slowly anyways. All right, good. And Joshman, can you hear me?
Hey, can you guys hear me?
Yes,
Yeah.
we can.
Awesome.
Okay,
Cool.
Good. We can start then. All right. So today we will have our second lesson about clean code, and the topic is clean code functions. We will try to find out what is a simple function. We'll be mostly analyzing the keep it simple stupid principle, how it applies at the level of functions, and it will be of 2 parts this time. First part will be theory, slides, examples, comparisons, and we'll try to analyze what is good, what is bad. And second part will be workshop. We will try to refactor code. Whoops. Okay. So,
Yes.
Knapp, you have problems.
Are you differentiating between functions and methods, or are you treating them as the same?
In C#, functions, all functions are methods because a method is a function inside an object. So in C#,
yeah, okay, so you. It's not very obvious in other language, so that's why I'm asking.
Yes, for example, in JavaScript, you can write objects and have methods and objects, but in JavaScript, not all functions are methods because they can be by itself. All right, let's get started then. So the first thing, the core thing that I think should be applied in many levels in different scopes of your program is the keep it simple stupid principle, the KISS principle. And what does it mean? What is a simple part of your program? What is a simple function? So let's start with the origins of this definition, of this saying. And it was coined by Kelly Johnson, who was a pilot and an engineer who was tasked to make spying aircraft. And he was challenged to make that as easy to fix as possible with minimal tools, with basic tools for a normal engineer in military and warfare conditions. And this was a challenge because usually such complex structure device requires complex architecture. But since you were tasked to make it easy to fix it, you had to make some simple design. And keep it simple stupid came from him, to design something in as simple manner as possible so it can be fixed as simple as possible. So to solve simple problems, simple tools are enough. And stupid here doesn't refer to a person who is stupid, but a solution who is so obvious to understand that basically anyone can understand it. So it's easy to fix. And now let's grasp some other principles which make understanding what is a simple function easier. And hello, Brady too. All right.
Your voice is echoing quite a bit on the stream.
Okay.
Yeah, it's echoing here too, actually.
Okay. I will mute it on. Okay, I will mute it here on Discord and let me know if you still hear an echo through Twitch. All right. So let me know if you hear an echo. Do you hear any echo?
All good.
Is it fine now?
Okay, no.
No, it sounds pretty good.
Okay, nice. All right. So
It's fine.
yeah. Also, guys, if you have any questions, feel free to ask in the chat. I mean, I'm talking about those who are watching.
Now I think
Yes. All right, let's continue. So the principle that I would like to cover now is Yagni principle, which says that you ain't gonna need it. And there is a nice quote by Albert Einstein saying that make everything as simple as possible, but not simpler. Please try to have push to talk as we hear background sounds when you type, whoever is doing that. So, as a quote to supplement the first quote, there's also a quote saying that it seems that perfection is reached not when there is nothing left to add, but when there is nothing left to take away. Meaning that being minimalistic is a part of being keep it simple stupid. Things should be just enough to use them. That way we save our time and save the effort of understanding all parts of some module. And here's an illustration. So don't use things that you don't need right now, and use as little as possible. Is all that there is to it. Before things can be usable, they should be reusable. That's true, but having as little as you need is enough. And here is a funny illustration saying, you can read it yourself, but essentially what it means is that sometimes we invest in stuff that we don't really need. And if in this example, for example, if we have something that it needs to have an awesome UI, and we invest our time into backend logic, super fast, super flexible, we don't need that. Our focus should have been different. And when you invest too much time into things you don't really need is when you might create unnecessary complexity, and you might also distribute your time resources pretty poorly. So final product is what matters the most in software development. Your system might be near perfection, but the idea which you implement is what matters the most. So you can look at the illustration and you will pretty much understand what I mean. And essentially what I mean with this point is that you shouldn't reinvent things that already exist, which are made for you. And keeping it simple and stupid means that you should choose the right tools for the right job. And the last principle for supplementing keep it simple stupid principle is dry principle. Meaning that every piece of knowledge, well, this is a quote by Dave Thomas illustrating the point, saying that every piece of knowledge must have a single, unambiguous, authoritative representation within a system. What does that mean? That means that you shouldn't have repetitions of the same in your code. It should have a single place to be referred for. So don't repeat yourself. That's what dry says. And so if you find yourself repeating yourself, you should split the code into functions, and there should be a single place where you look for a single thing. And functions should be composed of other functions, and they should be modular. But keep in mind that before software can be reusable, it first needs to be usable. And a nice tip that for functions, for level of functions, you should keep splitting them until there's nothing to split, nothing left to split. You should take them apart as much as you can until you have only the highest level calls. And a function composed of small functions like that will be super readable. So now some code examples. Could someone tell me what's wrong here? What's bad?
Oh no.
Well, you're doing some calculations at first, and then you're doing a comparison later in the same function.
Yes, that's true. So the first bad thing that we do more than two things in the same function. More than one thing in the same function. And the second thing is that our main function has some low-level stuff in it. It should simply have a call to some abstraction. And in our case, the abstraction will be just the function. So a call to some high-level function which does what we asked it to do. So something very high level is what should be in high level endpoints like main. Main should only contain high level logic, not implementations, by no means. So, and in this particular case, it's really clear that there are at least two parts separated with an empty line for, first, counting sum of numbers of square of a square basically, and then getting a sum of those numbers and adding them to a bank account. So summing numbers and adding them to a bank account is at least two things that it does. So the refactored version looks like this. Implementation is obvious, so I'm not revealing it. But there is still one problem here. And what do you think? What's the problem here? Where is the problem? What's wrong? What do you think?
The name of the first function is really long.
And what does a long name imply on? What does it mean when a function name is too long? What could it mean? Does it do one thing? And if not, what things does it do and how should we split it better?
It becomes cumbersome to use.
Yeah? Why? Why is it cumbersome to use? So basically, it's doing a count of sum of square numbers, but we're passing a string, an array of strings. But array of strings is I mean, we need a conversion, and this function inside itself will do the conversion, and we shouldn't allow that. So a refactored version would be splitting, getting numbers, summing them, and adding them to funds into separate functions. And now we have what we need. Though in this case it's still not that correct, since it's not just the sum of numbers, it's sum of squared numbers. So I should have left it like that. Change the name to like that, not just sum, to make it more clear that it's not just numbers, it's squared numbers. Or even better, make a new function which counts squared numbers. So a clean function is a function which is easy to use and change. And this applies to most of the things in code across multiple scopes of our program. Our code should be easy to change. A change is against what we design our code. And there is a nice quote by a member of the other C# Discord, Rightfault, which says that if you design for flexibility, you end up with complexity. If you design for simplicity, you get flexibility for free. And here we see an ugly validator where we pass an object. And the problem here is that validation is a complex process. And having a single endpoint for all of it, a single API call to somehow determine which validation we need based on upcasting is just a hideous implementation. So it's just not the way to do it. Why is it bad? Because if we need to change bank account, the way bank account is validated, we change the whole validation function and we might break it. It's a really bad thing, and a single change will potentially break everything. We don't want that, and that's why it's bad. And refactored version is where we split validation into separate validators, each having their own thing. Note here that I didn't use inheritance here for context, for inheriting context, even though you might think that it's the same thing. Or I could have made an abstract class implementing validation. Though that's not the way to do it, since inheritance will create a dependency and we don't want that. I will talk about this more later. This should simply have an interface, iValidator, and each validator should implement that. That's all. Not an abstract class, no inheritance needed here. Even though you might think there is a repetition for context, it's the necessary lesser evil compared to inheritance. So, functions should do one thing. They should do it well. They should do it only. And that's a quote by Robert C. Martin. If you haven't read his book, Clean Code, I highly recommend reading it because it's like a Bible of refactoring. It's amazing. It's great. So this guy is a model for clean code. He is awesome. And watching his speech is something special and always opening the way you think about programming. Anyways, a function should not have any side effects. So simply naming your function well should tell what it does, and it shouldn't be more. It shouldn't do more than what you tell it to do by the name. And nothing else should happen at the same time. A function should do one thing. So here we have a problem. And the problem is that every time we create a simulation, we will end up logging that we created the simulation object. And what if we don't want to have a dependency on a logger? What if we want to inject it? What if we don't even want to log overall? We cannot do any of that. And that's because we have a side effect in our function, and side effects should be removed. And soon you'll see how, one of the methodologies for it. Anyways, functions of same level of abstraction should stick together. And that's essentially what doing one thing means. Highest level functions will do more than one thing. But doing one thing means that you don't mix levels of abstraction. For example, you don't sum A and B and get a sum of numbers in a raw way. You hide that in a function if your call is on a high level, because you don't want to distort your vision with implementation when you're leading high-level function calls. You want to have all in the same level of abstraction. So don't mix it. And like that, when you have only high-level, like when you don't mix levels of abstraction in your functions, you will have functions no longer than 20 lines of code. So split as much as you can to the highest place possible. So you have logging in the run method, and it's a side effect. Logging is a side effect, and it should be split. And you split it in the main function, for in this case, the highest level possible. But that's not good enough. You can make it better. You can make logging optional and simply make an event, simulation started, simulation ended, which does what you want it to do. And here you subscribe to the event, simulation started, simulation ended, and in the main you register what happens when simulation starts or ends. So here's an example of how you could refactor. But in this case, if the scope is simple, small, it might not matter. But the more deep you go with your code, the more things like that will matter. So having no side effects is really nice. And in this case, you didn't really waste much lines of code, just removing and extracting that side effect. So like this, event is not a side effect. Event is a part of a function. Signals that it started, that it ended, that something else happened. It's not a side effect. Implementation bound to event inside a function is a side effect. And using events, you avoid that. So if you can, events are a nice thing, removing those side effects. And let me ask you, how much have you seen of a code where in onClick function you have, in onClick event handler you have implementation for some function where it implements what it should do, but it's not a high-level call. Do you see that often? Let me ask you that.
Yeah, all the time.
Yeah, and the thing is that it shouldn't be that way, because we don't care about details most of the time. We just want to understand what the heck does the function do? What the heck happens when I click the button? And here, if you refactor it perfectly in a high-level call from a high-level event, you will see that when I click submit button, I will save an account. When I click validate button, I will validate an account. When I click delete, I will delete it. So we don't implement low-level things in our event handlers. We call high-level functions. And don't be someone who calls themselves a copy-paste developer. You don't want to be a copy-paste developer. You don't want to reuse your code by pasting it. You want to reuse your code by calling functions. Pasting code is the worst thing you can do, simply because a change in such code will require a change across multiple places. And you want to centralize such change, having a single point where your functionality is defined, a function. Like that, you build trust for code and easier changes. And maybe potentially usability beyond scope of a project. All right, so functions should be short. Coding, like poetry, should be short and concise. And I think everyone agrees. You don't want to waste your time reading too much, too long, unnecessary code. Code should be like a chapter of a book. So, can someone explain what that means? Well, it's written, but still. What do you think does that mean? that at the top we have highest level functions. The more down we go, the lower the function level. Step functions not used outside should be kept private. How do you imagine the layout of a code like that? Anyone?
It makes it readable for maintaining the code.
Well, the chapter or the title of the chapter describes what the chapter is about.
Yeah. All of that is true. So essentially what it means that a chapter of a title is a high-level function. And a high-level function can define how we call a paragraph. A paragraph can define how we call sentences. But that's about a book. And what about the code? So here we have an example of properly laid out code. We write a coding story. So we write an intro, then chapter 1 to 3, and then the ending. And the write method is pretty much obvious. I think everyone would write it like that. But the point here is that the way we lay out our method definitions is the way they were called. And we put highest level methods at the top. And down the more down we go in code, you get lower level functions. So like that, when I was giving this lesson at work, someone said that we can use Ctrl F to find the function that we want to look at. But with this kind of layout, you won't need Ctrl F because basically in a single screen without scrolling, you will see a function and a depending function. And you will need maybe scroll a bit, but essentially you will see all you need to see. So like that, you have clean layout of your code and clean code. It is a small detail, but it helps and it saves your time. Someone at the start of the lesson said that a small function is a function which has few arguments. And ideally, a function should be no bigger than 2 arguments. The more arguments, the worse the readability. I think everyone agrees. So here we have a static class called shape calculator. Static is ugly. Here it's okay-ish. It could be worse, right? But anyways, you have static methods which calculate rectangle space. A better word would be area. So rectangle area and rectangle perimeter. So you pass width and height for rectangle and you get back the things. For echoing, I hope it won't. I really need to test this before starting. I'm sorry, guys. I'll try to video edit that. Okay. So you have shape calculator. Could someone say what's wrong here? What is bad? What is bad with this kind of implementation? And how would you suggest to make this better? What do you guys think? Okay, well, a hint is few arguments. How could we make this so that we don't need to pass any arguments at all to the function? Does anyone have an idea? And someone wrote, pass a rectangle object, take out arguments. Well, what if we move space and perimeter functions to the object itself? So now we don't even pass any arguments, and we have a rectangle object with height and width, and we pass all that we need for a constructor. So space is calculated without any arguments, and so is perimeter, because the internals of a rectangle tell how to calculate it. All that we need is inside the rectangle. We no longer need to pass anything. And this is almost, but not really, a principle of tell, don't ask, where we no longer need to pass anything to a function. We just simply tell, say, give us space or perimeter or whatever, without the need of passing anything. And a function with 0 arguments is the most clean function ever. Okay, and in some cases we cannot get rid of arguments, but we can encapsulate them, encapsulate the related arguments. Here we have an airport checkout point and a checkout method, which takes in 1, 2, 3, 4, 5, 6 arguments: name, surname, booking number, date, person ID, airline. How would you refactor it? Does anyone have an idea? I'll wait half a minute. And if nobody has an idea, I'll reveal the solution. Anyone? All right. If the parameters are being used in multiple methods, then they should become properties. Create airport class and a person class. Kind of. C#, yeah. I wouldn't agree that we need an airport class, because simply those parameters represent a ticket and a person. So yes for a person, no for an airport. We don't need an airport, all we need is a ticket. So a set of methods and take out parameters. Kind of, but the high level call would still be the same. Make a class and send that object to the method. Yes, so we have 2 classes, person and ticket, that we send to the checkout. So now we grouped our parameters together, and we no longer need to try to understand what they mean by itself, because we have high level abstractions that tell what it means for us. All right. So pass. So Fox Fury Fox. I'm having a hard time reading on it. Fox Fire Fury said. Furry said. Oh, I see. So the parameters are still there, but they are abstracted behind the classes. Yes, that's exactly the point. One of the principles of object-oriented programming is abstraction. We abstract away the details, we abstract away the things. Another principle is encapsulation. Encapsulation is abstraction, except that we hide the details that we don't need to know about. So there is a case, let's move on. So there is a case, and a really, really often case actually, we pass something which contains something that we need, but not quite. Something more than we need, a part of it, but not entirely. And in those cases, we should refactor it to just take what we need, split it. For example, if we need a person's first and last name, we shouldn't take the person class. We should simply take first and last name, 2 strings, nothing more, nothing less. So pass logically grouped minimal parameters that you need, because There are often cases where when all we needed was a banana, but we also got 2 monkeys and a whole jungle. You don't want that. You want to be minimalistic. You want to keep it simple, small. You ain't gonna need it. Follow Yagni principle, follow Dry principle, and keep it simple and stupid, like that. So, functions are heart of a program. And keep in mind that the rules that apply for a function apply to other scopes as well. To class, project, and solution itself. Speaking in terms of .NET, of course. Well, it applies for other languages too, but specifically for .NET, those are the scopes that you have essentially. So, big, complex, stable software is only possible with a stable core. Functions. Having modular parts of your software makes it easier to change. Having them easier to read reduces the time you need to take in order to understand what goes on. So keep it simple, stupid, modular, dry, follow the you ain't gonna need it principle, and you will have clean functions. And that's all for the theory. And now let's move on to the workshop. Who wants to do workshop? Could you write in chat on Twitch? Who wants to do it? We will be having a workshop about refactoring code from bad version to good version. All right? So for it, I will give you a Git repo link. Right? Source, functions, whoops. Okay, here you go. Also a link to slides. I should have posted it at the start, of course. So if you click the GitHub link, and if you go to the master branch, I recommend checking it out, cloning the repository so you can see, and we can go for refactoring. And I will open my Visual Studio. Next time I think we'll do it a bit differently. I will even share an invitation to my Visual Studio for Visual Studio Live Code so we can all work together on the same solution and maybe simultaneously refactor it with ideas that you think should work. All right, let's get to it. So here you also see lesson 3 and lesson 1 material. Lesson 3 is not finished. Lesson 1 is finished. And in general, this workshop solution has 2 branches. Master is for dirty solution, and clean code branch has a refactored solution. All right, so let's start. Let's start from quotation import. This is fine. Specifically, oh crap, errors. Let me fix them. But yeah, in the meanwhile, familiarize yourself with the project, with the solution. Okay. We don't need that. And we definitely don't need that. Okay. Now it's good. Okay. So here we have a quotation window, and that's the main thing that I wanted to refactor. A quotation window. And what do we have here? We have an onClick method, event handler. Imagine that this is an event handler when a button, when an import quotation button is clicked. We do this thing. What is this thing? Well, let's read it. We create a quotation importer, log that it started, and we start the transaction. And when then we do a bunch of things with a quotation, we commit a transaction if all was correct. If not, we roll it back, and then we say that we're done. So basically, we create a batch of entities. What do you think is bad here? What's wrong? How could we make it better? And I would like also to discuss this with Joshmont as well, as he wanted to help, so I would like his input as well. You can write in chat or in voice, however you prefer. All right, so essentially what's bad here is that we have low-level stuff in our event handler, in our onClick. We don't want that. Sorry, okay, I didn't notice that Justman wrote something. So the handler is doing too much. It contains a lot of logic which can be split out more. Yep, that's true. It's doing too many things at once. And we want this button to do one thing. What does it do? Well, it imports a quotation. Yep. So basically, actually, there is a keybind, not a keybind, but in Visual Studio, in ReSharper, but in ReSharper you have Refactor. It's essentially a menu called the Refactor, and you can just extract a method with a button click without caring what you need to pass, what you need to return. And here I want a local function call, a private function. So I just clicked it, and here we go. We have we should have gotten a method, not a local function. Don't do local functions. Okay, method. Cool. And call it import quotation. Right. Also, another thing is that we shouldn't call those things separately. There is a term for this, a code smell. It's called shotgun surgery. We need to handle validation of header and lines, creation of header and lines. We don't need to call those separately. We don't even need to know they exist. We should call it in a high level. So this should come from a quotation importer. Also, Joshmont, just keep saying what you think about this whole thing, and we will review it. After, in the meanwhile, in the meanwhile, while I'm refactoring this. All right. Let me. Nah, whatever. Okay. So here, this part should go to a function for importer, and high-level function. And how we'll call it? Simply as it is. Public void import quotation. And now we don't even need importer. We had so many calls to importer. We took quotation. And now, right, and now we don't need that. Also, here is a problem. Here is a problem that we consistently pass a quotation. in every method call, and it's kind of redundant. And since quotation importer will be per quotation, we can pass a quotation in its constructor. So if we do this, we no longer need to repass it in method calls. Also, having DB context as public is simply stupid because no one needs to know what's inside this importer. And since it will be private, it will be a property. Right. Context, and quotation. So we have a quotation, a private quotation, a private context, and we set them. What do we win? We no longer need to call quotation here because it's all inside. Of course, I could have just right-clicked and rename all, but whatever. Here as well. Okay. Now we don't need importer. Calling something from something multiple times is an indication that you can group something, that you can refactor it. Passing the same parameter redundantly multiple times is also a sign of having something dirty. We don't need that. We don't want that. So here we definitely don't need to have a quotation passed. That's enough. And here we just pass the things. We don't need to pass quotation. We have a private field for it. So it's much easier that way. Right, and we're done. So, here, a few more. Right, and here. Right, and we're done. Now we have an import method, import quotation method. We have we'll assume that we have other things, but the thing is, right, so now we need to create a constructor where we pass a quotation. There is, how do we pass a quotation? Let me think. Here is a quotation, so we pass it from here. Don't mind this, it's ugly, of course, it shouldn't be this way. Parameters constructor constructed. So Judgment said that if you're going to refactor the quotation to constructor, it may be a good idea to create a parameterless constructor, or a constructor that just takes in DB context as well, for the case where we want to make a call to DB context but not pass the quotation directly. That gives us more flexibility and it makes us insure it for other cases. So we might as well just do that. The thing is that the context is essential. Without it, we won't be able to do any import. The layer of persistence will be gone. But on second thought, the quotation itself, we might set it externally. It really depends on point of view, but it depends. So we might have instead a public method. All right.
Oh, what's up?
Hello, hello. Waffle
Hello.
just joined. We're doing a workshop
Hello.
right now. and we are refactoring code. Give me a moment. So I'm waiting for, in the meanwhile, what Joshman writes. I will write to one person fast. Where is he? Give me a moment. In the meanwhile, have a look. Think what you would do. What would you change? Okay. So, yeah, having three constructors. Okay, bye-bye Teklum, and thanks Joshman for that. Could you explain why would you need an empty constructor? What do you gain from empty constructor? Because we won't be able to work with a quotation we won't be able to have a quotation import without some sort of layer of persistence, some sort of DB context, and we won't be able to do it without the quotation itself. We need a target. So why would you need the two? Because I personally, for this particular business case, I would follow Yagni principle. Why would you need the constructors if you ain't gonna need it? Because later on, if you allow the two versions of constructors like Joshman just showed, with this, the problem here is that in all parts where I import quotation, where I read header, where I validate header, where I validate lines, I might need to simply validate. Did I not forget to set context? Did I not forget to set the quotation? And with this version here, we enforce that, and no extra validation is needed because that's how we define our constructor. We could of course add attributes, not null and so on. But yeah. So Joshua says that in this case it may not be necessary, but in general it's a good habit because C# doesn't automatically generate a parameters constructor once an overall constructor has been created. And that's definitely a good point. Once you have this constructor, you won't be able to say new quotation and pass no parameters because by default, just like Joshua says, C# creates one for you because you need to call new in order to create something, in order to allocate memory to a reference that comes with the object. So, in this way, the way we have it now, we enforce that we take two parameters and we should null check them as well, but I won't do that for now, for validation reasons. So, you should. This way, you basically tell anyone who uses your endpoint, your API, your quotation importer, that the quotation import cannot happen without providing the two, the context and a quotation. So I import a quotation, I set a transaction, that's how import quotation happens. Let's go back and let's fix some errors, right? Quotation underscore, let's continue. Alright, all good. Here we have another problem, another method, another call. Here we have button update quotation on click, which implies that this part updates a quotation. So we should refactor it somehow, and we shall. Alright. Here we should put this, of course, there so that it's doing what it did before. And here we should somehow split it into a method. We call this here, of course, and actual start is here. So just like the other case, we refactor this nicely. Now this importer we still need to create. That's true. But this method, which does update quotation, can be refactored inside. And so now I'll show you one thing. Anyways, it should go to the top. It's the highest level call. So it goes to the top. And let's name it. So I'll call it public void update quotation. So we update a quotation that we have set within our importer. No longer need that. And we have this. We actually, why do I accept that? I don't accept that, so we don't even need those. So now we have this and this and this. And context with underscore. We don't have importer, context with underscore. Underscore. Context with underscore. Quotation. We don't need quotation. So we read header, we check if the header exists. If it exists, we update it. If it doesn't exist, we only if it exists, we update it. Otherwise, nothing happens. Something like that. Don't put too much attention to the implementation itself. The focus is refactoring this ugly code. So now instead of having a ton of things done here, we can simply say importer, import quotation, update quotation. Now, another thing that's bad here is that if we say, like, if all our importer should do is update and create quotation, we don't need to see all those other things. And since we don't need to see all those other things, we should keep it simple, stupid, to make as little possibilities to mess it up. We should make our functions that we don't need private. Because like that, we create a really simple API to use without the things that you ain't gonna need, following the Yagni principle. And I'll just better off copying it. So paste, paste, paste. And we have two high-level functions, which we call in import window. And now we made it really readable. We know that when import quotation starts, we log that it started, and sorry, I didn't call the thing here. So importer, import quotation. So we know that when import quotation, yeah, like that. And here we say private void update quotation. Highest level calls. Now we have one more thing that we could do, but it's not really necessary. we could refactor this into this with splitting one-liners into functions, expression into arrow functions. Judgment and others as well. What do you think about this? This way of implementing an event handler, for example. Is this clean? What do you think? Having button on click with an arrow function. So Judgment said that he doesn't use lambda expressions that often because it makes code a bit harder to read. But his point is that it in the end becomes on your habits. And I definitely agree with the last thing that he said, that programmers with functional background, for example, Haskell programmers or JavaScript programmers, like all JavaScript programmers, will probably prefer this style, but I personally don't, simply because when a change will need to happen, you will need to delete the arrow, add the brackets, and add another line. You will spend a bit more time implementing this kind of thing. You don't have to do that when you have brackets. So it's just a way of wasting less time when a change happens. So now we have a refactored version with a quotation import window. And now there's a bit bad thing because we have those next to each other, but we actually should have those aligned in the way they're called. These two are the highest level. These two are a bit lower level. They're high level calls, but a bit lower. So they should be split. And hello, Richard DBA. All right, let's move on. Static helpers. Here we have a static class. Dance with me 123 said that in this case it doesn't really matter because it's clear either way what the function does. In this case, call another function. That's true. That's also true. All points are valid. Nice. All right. Here, collection helper. We have a static class. Static. Ooh, static. Static is bad. Many people say that. All right. And we have a toString method. First bad thing about this is the naming. ToString will be ambiguous with the string of every object that every object has. We don't want that, right? Convert to string is a bit better. Naming is really hard for a programmer. It's one of the hardest things that programmer needs to do. So picking a name should come naturally. It shouldn't come instantly, but eventually it will happen. So don't force yourself to come up with a name, with a good name immediately. Let some time pass and it'll happen. You'll do it. So take your time picking a good name. Anyways, convert to string. Let's settle for it for now. We have a static string method which targets a collection of objects. Enumerable of objects, a generic collection which can be iterated through. And what do we do with it? We simply convert each element using that element's toString method. This will, this is missing also brackets. Oops. God damn it. Okay. This is missing like this. It will take arrays, it will pick the index method element of the array and will convert it to string. Internally, that's what it does when you do string interpolation. String interpolation because you have $sign. So it will convert index element of the array to a string. And string builder is used to convert complex strings. In this case, it's a loop. It might have too many elements. So for performance issues and stuff like that, it's a bit easier to have a string builder. Also, we use append line. Otherwise, we would need to do at the end of the line, something like this, rn, which is end of line symbol in C#. We don't need that. We don't want that because we use string builder. So this part is actually clean. This part is clean. This part is good. What isn't good here is the fact here is not so clean part, because all we need here is essentially an index. We want to say which element was printed. But since IEnumerable doesn't have an indexer, it simply can be iterated through, we don't have an index. But array is a bit too much. We don't need an array. We don't need to do all that conversion just to be able to get an index. What we want is to be able to have an index. So I simply write index equals 0. And now I will do a for each instead. So for each element, more like item in collection, and I will no longer need index, and in the end, I plus it. So essentially we have the same, but with elements, just the elements that we need, just what we need. We followed you only gonna need it principle and we moved the to array. It might be confusing. We don't need that. So we refactored it to what we have now. Now another thing, methods, especially static methods, which target a single object, should be an extension. Here we have collection being targeted, and we want, we will always be calling collection helper dot convert to string, and we'll pass a collection. What we could do instead, make this an extension, like this. That's all there is to it. And now when we have a collection, we can do simply convert to string, and it will convert to string. So instead of having kind of a bigger, longer chain of calls and having the need of know where it came from, we can simply call it through the target for which it was dedicated through an extension call. Last thing that I don't like in this function is that it only works for objects. And like this, it will work for everything. So another thought that helps. Now, there is a tiny difference between IEnumerable, a generic IEnumerable, and a non-generic IEnumerable. An example of non-generic IEnumerable is an array class. So if I write this like that, like this, and I say that it's equal to one, two, three, and if I say, if I try to do a convert to string, you see nothing happens. If I change this to var, now we see we can do it. So, okay, Someone joined. Hi, I'm new. The Spice Phantom said, "Hi, I'm new to programming, and I really need to take a lesson at local school. But having someone to explain what he does is perfect." Could anyone try to explain what is this all about? And meanwhile, I will continue refactoring. I would appreciate if someone would take some time. Also, the Spice Phantom, take your time. Take it slow, take it easy, and after this I can give you an invitation to a community where we can help you with your programming questions, where we can help you answer questions, help you find your way into development, help you with career questions, career paths, and other things. Anyways, let's continue. So here, if we write var array, we have array in general, a simple basic array like this, is IEnumerable. It's convertible to IEnumerable implicitly, to a generic IEnumerable. But here is not. It's IEnumerable, non-generic IEnumerable. And that's why it doesn't have convert to string method. So the problem here is that this thing does exactly what this does. But we don't want to repeat ourselves, do we? For that reason, we don't need any of this. We want to treat this collection as this collection. We want to treat a non-generic collection as generic collection. Oh crap. I'll put it a bit closer, sorry. Is it any better? I hope it's any better. I really need to do some testing. I didn't have much time today, sorry guys, but I promise it will be better the next time. Oh, damn it. I hope it will be better next time. I'll try to figure out. Sorry. Really sorry. Okay. Maybe some update, I don't know. Anyways, the problem here is that we need to find a way how we convert from one collection to another. So we need to convert this collection non-generic collection into collection. Non-generic collection into generic collection. And collections have this method, and this kind of non-generic collection is a collection of objects. So I simply convert a non-generic collection into collection of objects. And like this, I can call in the end this. And instead of re-implementing this, we simply solved a slightly different kind of problem, which is adapting existing solution to a different data structure. So we essentially made a small, tiny, basic adapter here, converting one type to another, and then doing what we can with the other type, which has the functionality that we need. So here we have just what we need. Clean version of otherwise static methods, non-extension based. Here, since we targeted a single parameter, we can simply convert this to an extension with a this keyword in C#. Let's move on. This one is a tough one, really tough one. Really tough one. I am intimidating you, but it's really hard. A mess. And someone who wrote this code should be punished. And that someone is me. I'm sorry, guys. So first, let's just get rid of the obvious. We create those, so we don't really need to know what the type is. This static, really? Why is this static? I have no idea. Don't do this. this is not static. Anyways, we have a method. Pick a gift. Basically, we have this input. So let's start from the start. Name, gender, age, and eye color. It really sounds like properties for a person. So we can definitely split this into a person. Let's do that. So if I go here, I will say person. And here, I will write what a person has. So a person has a name, gender, age, and eye color. Okay. I will say in advance that eye color will not be used, so I'll just delete it. It was my bad. So I'll make this all public, as we will need to use it. Now, this is a class, but it's more like a model. Since this is also very small, we can use a struct instead, because it's a small data model and it doesn't have any behavior in it. It's data essentially, and to make stuff data, we can use a struct. A struct should have read-only fields, since structs essentially are designed to be immutable. So like this, we have name, gender, age. Gender, on the other hand, is, well, I'll be progressive, so let's define gender. It's an enum, essentially, with values such as, what genders are there? So we have male, female, and I'll be very progressive and say other. So we have such genders. And here, it's not a string, it's a gender. Good enough. That's all. Basic struct for a person. Now, let's go back to gift randomizer. So we have a hint. Based on multiple criteria, a gift will be picked from a gifts pool. So we have a person as our data model, based on which we will filter out the possible gifts that that person can get, and in the end, we will get a random gift. Joshua suggested that we might want to make properties, but we already had this discussion in the C# in community that a struct should not be property based. It should have read-only fields. And this is the only single case where you'll have public fields in C#. Otherwise, for a class, you'll always have properties. So I'll follow, I agree, I get what Joshman says, but I would also like to follow the Yagni principle that for the time being, you ain't gonna need it. And if you do, all it takes is to write this. And this is really not that hard of a change, and it doesn't really cost or affect anything. It's gonna be simple to implement. So I would stick to this version, because a change here will be really basic and simple. And struct here is a bag of data, as opposed to, if we go, let's say here, here, quotation importer which is a bag of functions. Anyways, let's go back. So let's refactor it a bit. Gender. So if gender is male, we will be comparing other things. So let's go to the highest levels first. So I took care of this if, now let's take care of this if. So gender is female. I'm writing this because by not using strings and instead named values like enums, we are preventing the developer of making a mistake. Really? 22 times? Yikes. God damn it. Well, I'm sorry guys. Sorry for the quality. Earlier you said structs are practically designed to be mutable. Don't you mean unmutable? I meant that structs are immutable. So sorry, it might be my voicing, but I meant that structs are supposed to be immutable. They are designed to be fast and small, without a change. When you create it, you shouldn't change it. You can change it, but you should not, because that's how a struct was designed. Struct is a data type for encapsulating data, for abstracting away, grouping away parameters. It's really ideal for that purpose, I would say. I would argue. Alright, let's continue. So, person, age, less than 2. Here we have 2. 2 is a magic number. So let's make it not magic number. So we have person 2, so const int, and 2 here was a toddler age. It's really hard to pick a name for a constant because you not always know what this means when you find it like that. But imagine that you knew this initially, what this means. So you can simply write it like I did, with named constants. So you refactored this 2 magic number into named constant. And this is not just toddler age, this is, oh crap, this is maximum toddler age. Toddler age limit, maybe. Yeah. All right. And here we have this, and let's refactor it to, crap, why can't I refactor? Let's refactor it to teen start years. Kid age limit. And I'll read what Joshman said. So the main difference between a class and a struct is how they are stored in memory. A struct is placed on the stack while objects are placed on the heap. Structs are good for small units of data that perform fast computations because the stack is very fast at processing, but it can be size of the stack is limited. So essentially what he means that when we work with structs, we work with copies of data. And that's why copying big amounts of data is bad. So if your struct is big, it will copy lots of data. It's bad that way. But if your struct is small, you work with small copies, and that's efficient. When you work with classes and objects, class objects, you work with references, essentially, when you're passing a class, with copies of reference rather than a copy of the object itself. And that's the key difference between a reference and a value type object. Essentially between an object, a class object and a struct object. Right, so we have this constant, person.age, have it here. And we kind of made it fit our person structure. Let's continue. So if person.age is less than toddler age limit, so what do? Essentially, we pick a size and a color based on the age. A size and a color based on the age. Right? So for children for people under toddler's age limit, we will pick these things. We will make these pools for people of this criteria. We will pick these pools, and basically, if you are above kid age, you will not get anything. Right, and here we have the same as well. So let's refactor it. Actually, let's put it all the way up there because we want to reuse those age constraints. All right. This condition was bad. I made a mistake there because it's an impossible condition. I can show you again. So if my age is less than this, then this will be hit. So I shouldn't check this twice because it makes an impossible condition, so it's useless. I can easily refactor that. You ain't gonna need it. It's impossible. Don't do it. Don't use it. So you have this. In that case, if it's simply a logical error, then you can easily remove that kind of statement. Okay. Let's see what happens. So we pick gifts for a male. We pick gifts for a female. For other, we don't pick gifts. Probably for someone to identify themselves, their gender as other, it needs some time. So we don't even take that in consideration because for a kid, it might be too early. I'm not being genderist. I try not to be. Okay. Anyways, so we pick different gifts. We make different gift pools per gender. And yeah, that's a lot of repeated code. So let's see. Size pool is the same. Size pool is the same. So we can make a conclusion that based on gender and age, we can pick size pools. So let's make a function which does just that. Also, right, so let's make a function which does just that. Pick size pool. Of course, the type void. More like maybe a float, array of floats. For returning something, I always do as generic as possible data structure. So IEnumerable, if my intention is to iterate through, then I should reveal my intention with an appropriate data structure. IEnumerable is an appropriate data structure showing my intention. That's what I need. I don't care if it's a list, if it's a dictionary, if it's a other collection. I just care that it can be iterated through and it's generic. All right. So pick size pool based on what? Based on age and gender. So I pass age and gender, just what I need, not the whole person, but just what I need. So age and gender. And Right. So I will simply put this inside. And I will do the checks here. Now we don't need person anymore. The age is here. And the great thing about this is that this part is now coming here to the function scope, to the slightly lower level function scope, not the highest level function. All right. So first we filter out if it's a male, and we create those pools. So what we want is I enumerable float size pool. Right. So we don't need to work with colors anymore here. We can safely delete all that we mentioned colors at. And based on age and gender, we will filter it out. Right, so age and gender. Okay. So, and in the end, we will return size pool. Yeah, this code is ugly and we're trying to make it better. Why is it saying something as it is? It might not be initialized before returning. So we need to explicitly say that it's null. If all cases fail, if nothing is found, it's null. We couldn't find it, and that's okay. There are those cases. We didn't throw an exception here, by the way, because it's a valid case. It happens too often to be considered an exceptional situation. So we simply return null. Okay, so if gender is male, we have this, otherwise we have this. And let's look at it again. This repeats itself. This repeats itself. Hey, this is not even based on a gender. This is simply based on age. Gender is not a factor. It's irrelevant. Size will be based on age only. So now we basically have this for all the things. And this is already much better, but let's make it even better. Okay, so what could we improve? This is pretty good, actually. Well, nah, this is pretty good, I think. Yeah, I think so. So right now we have a function yes, and that's what we're doing. Oh, right. Age is more than toddler, and age is that. Right now, this seems to be logic error because it's possible to be an age satisfies both conditions. No, it's not, because first this will be checked. So if age is, let's say, 1, this will happen. If age is 3, this will happen. If it's 1, this will not happen because I wrote else. So it's not really true. So I wouldn't write the other end statement. And I think this is okay. So now we can say that size pool is here based on person.age. And now we need to get rid of a size pool because we already sorted that out. And naturally, what we do now is we are picking color pools. So we need to figure out how do we pick color pool. So color is a string, but it's simply a string because we don't want to make it we don't want to spend too much time in designing color and defining our colors, so whatever. Right, let's continue. So pick a color pool based on what? Now gender and age will be factors. So based on age and gender. And I'll move this here. And I'll say person.age, person.gender. All right, and let's continue. Right, let's continue. So let's move all that's left to the scope of that function. One thing at a time, step by step, step by step. We will have, again, enumerable of strings, genders, and we can check gender, person, age. First, let's just fix those errors. All right. And this is not genders, but this is color pool. Okay. Now we have a little problem. We have use of those across our application, our class, and we want to make them here. We want them to be usable in both functions, so we're inevitably forced to put this as a field rather than as a constant field rather than local variable. And the convention says that it should be Pascal case, and so I do just that. And now pick color pool returns again a color based on those criteria. This time, this time on age and gender. So let's try to make this even better. If we can, of course. Here we have basically 4 different cases. And all those cases are unrelated, actually. Joshmont, in .NET, in C# at least, we follow Pascal case notation. All constants, all capitals constants are in Java, for example. All capitals notation is called Hungarian notation, and we don't follow that in C#. Though it all ends up in your style. As long as you're consistent with it, you should keep to it, and that's fine. But in general, without having any predetermined standards, in .NET we follow a Pascal case, which means every first letter is capitalized as long as it's a class or any other data structure name, as long as it's public, or if it's constant, or if it's a function name. Then it should be Pascal case. All right, last things. So here, unfortunately, we cannot do anything. And even though it looks not that great, that's what we had. That's what we end up with. So we filter out a size pool and color pool based on conditions, based on properties of a person. And here we do something else. One more thing. And this should be split into a function. I don't know what this function does, but I have a feeling that I know, that I might know what it does. So here we pass in we got the gift there, so gift color, and this is private. So pick a gift, random gift, and we pass in what do we pass? Gifts pool. Gifts pool color enumerable string color pool, and enumerable int, sorry, not int but float size pool. It's not that great, but there's one thing we can still do, but that'll come a bit later. So for now, let's just write return null, and let's implement it. So paste. What's happening here? We filter a gifts by their size and color. So we get all valid gifts by their size and color. And what does this do? It's a bit nasty, actually. This shuffles the list. And in the end, in the previous implementation, we did this. And what this means is that we filtered out the list and then we shuffled it. And then we got the first element from the list. It has a few drawbacks, this approach. And what are the drawbacks? Well, we need a gift, yet we convert to a list in order to achieve what we just did. We don't really need to do that. So what we can do is first or default, of course. So now here we will have a single gift. A gift, I'll just make it gift. And we return a single gift. And that's it. If you want to go for perfection and seek it to be really, really modular, you can split filtering and picking random one separately. Well, this is a bad thing. Maybe it's less code, short, but we didn't need to shuffle a list, and this line essentially does that. So this is a bad approach just for that reason, and we should refactor it. So what I suggest is to refactor picking a random gift to two parts. So first, filtering gifts by criteria, like this, and then figuring out the best way to to pick a random gift, which should be a generic solution, which could be a generic solution, as we pick a random element from a list. So gift, and here we return gifts filtered, and so this will go into a method of its own, and I'll call it filter gifts by filter gifts, just that. Hello Ernukas, and we pass in gifts pool, color pool, and size pool. So we have this, and lastly, of course this shouldn't be static. Actually, it's not a bad thing to have a private static method, because this one doesn't use any internals or class, so it's by itself a bit faster. Static is not being called for a reference, so it's slightly faster. So having private static without state, without any state inside them, just getting the state as parameters, it's quite good. And I think the echo returns because I talk too loud. Okay. So pick random, from gifts pool, and just gifts. Oh damn it. Okay, and what do? We have all the way up there a randomizer. So, we have a randomizer that we created, that we should create in a constructor. Gift randomizer, and random. Right, and lastly, if we go here, we can say var index is random. Come on. Right, this is a static method, so now I cannot use static because I'm using a field, a randomizer as a field. So if I do this, next, and I say how many gifts there are, because I want to get an index no bigger than gifts count, I can do this and say index. And essentially a little problem. This is enumerable, so I still need to convert this to something that can be iterated through. This is not the cleanest solution, but it is a solution nonetheless with few lines of code. So it's not that bad. And essentially, right, I didn't write a type, so we return a gift. So essentially, gifts filtered, and then we pick a random gift from our gifts filtered. And we return that gift that we picked. And here we pick
What's up? What's up?
simple gift. Okay, and what's left? We don't have this anymore, and now we have the last call to our function. We have gift, and we say pick random gift by gifts pool, color pool, and size pool. Dance with me, 1, 2, 3 set. So if we reuse gift randomizer, the random object will keep its seed. Isn't it something we want to avoid? Sorry for being nitpicky. In this solution, since we don't recreate a randomizer, let's say here, it will generate a random number, and that's all that matters. That's what this solution is all about. So seed here, I don't think it matters that much unless I have some misconceptions about how randomizer works. In this case, if we call pick random, every time it will be a random number, not the same number. If I did it like this, here, and in this case, every time it would be the same number. So I'm not sure what you meant. But yeah. So yeah, now we can collapse, 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 collapse. So we pick size pool, we pick color pool, and we pick random. No worries. All right, so we just refactored this. The last thing that we could do is putting pools as fields in our function, because you see, in our class, because as you see, we put them in this place, we put them in this place, we put them here. But the problem with this approach is that if we indeed have multiple pools, changing pools from the outside, then we will have to recreate those gift randomizers. And if our gift randomizer works based on different gift pool and person, well, well, actually, it still works. So we can split size and color pools as fields, just because we called them so many times in our private functions. So let's do that last thing. And do we have a nice refactor? Introduce field. Private size pool, how does that work? Well, isn't that just lovely? Let's do it for all. I'm simply moving local scope functions. This is fine, actually. So right now, the benefit that we just got is that we no longer need to keep passing all the same variables, we can use the internals of a class. So here we do this, here we do this, and here we don't need to do this anymore. And so this and this, they simply are no longer used. So pick random gift needs gifts pool still. Yeah. So now when we read this kind of version of a function, and when we look at the high level, public is always higher level than private, no matter what. So when we read this kind of implementation, we see that what do? We form pool for size, pool for color, and then using gifts pool, we filter out a gift randomly that we need. And private fields imply that those they will be used somewhere internally by filtering out the gift. And here's a small refactor. It should be underscore size pool for private fields. And constant should go at the top. And that's about it. That's all I wanted to show for today. And with this, the refactoring is done. Thank you for your attention. If you want to have, well, I will post all the info, the slides, I posted already, the workshop, I posted already. One last thing, if you're curious, I can give you an invitation to a community where we do more lessons like that, where we help people with their development questions, where we simply want a developer to become a better version of themselves every day. So if you're curious, here's an invitation to a community. And that's it for today. If you have any questions, feel free to ask me. In this community, you'll always find me. So that's it. Also, there is a Reddit post, if some of you came from a Reddit post, in C# subreddit and in Learn Programming subreddit. So I would appreciate that you would post what you think about the lesson and what you would like to improve, what you didn't like, what you liked, what would you like changed. I would appreciate all of it. Thank you for your attention and see you next time.